Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if computers could read research papers like we do to figure out which ones are important? Well, this study dives deep into just that. Imagine you are trying to find all the research ever done on, say, why some people procrastinate more than others. You'd have to sift through thousands of study titles and short summaries called abstracts. It is a mountain of reading, super tedious, and easy to miss things. That is where this research team stepped in. They explored using something called large language models, or LLMs, which are basically super smart computer programs like the ones that power things like ChatGPT. Their big idea was to see if these AI models could do the heavy lifting of sorting through those abstracts, saving researchers tons of time and effort. Think of research synthesis as putting together all the puzzle pieces of existing scientific knowledge on a topic. Abstracts are like the tiny pictures on the outside of the puzzle box. You need to look at them to decide if the puzzle piece inside the full paper is even relevant to your picture. This initial sorting is called abstract screening, and it is a huge bottleneck. Humans are good at it, but it takes forever. So, the researchers in this paper wanted to build a system to help AI do this job. What is really cool is that they didn't just say use AI, they actually created a step-by-step guide. First, they broke down a big pile of research abstracts into 3 groups. One for training the AI, one for testing it, and then the main group to screen. Then humans went through the training and test groups to label which ones were important and which weren't. This is super important because the AI needs to learn from examples. And we need a way to check if the AI is actually doing a good job. They also got really technical about how to communicate with the AI. This is called prompt engineering. It's like telling a very smart but literal assistant exactly what you want. They experimented with different ways of asking the AI questions. For example, they tried giving it just the rules for inclusion, that is 0. Short prompting, and then they tried giving it the rules plus a few examples of abstracts that fit or didn't fit. That's few. Short prompting. It is like showing a student how to solve a problem versus just giving them the formula. They also focused on how the AI should give its answers. They wanted structured answers, not just a rambling paragraph. They wanted clear yes or no for inclusion, or even a breakdown for each specific rule. This structured output makes it way easier to compare the AI's decisions to human decisions later on. Think of it like getting your homework graded with specific points for each question, instead of just a single overall grade. And here is a really clever part. They knew that even smart AI can sometimes be a bit unsure. So they had the AI screen each abstract, not just once, but multiple times. If the AI gave the same answer every time, they felt more confident in its decision. But if the AI waffled back and forth, saying include one time and exclude the next for the same abstract, they flagged it as uncertain. This uncertainty is crucial because it tells researchers exactly which papers need a human to take a closer look. It is like a built-in way to catch the tricky cases. They even compared different AI models. They looked at big, powerful, cloud-based models like GPT from OpenAI and smaller, open-weight models that could even be run on a researcher's own computer. This is important because it shows that there is a range of options, and sometimes a simpler, more accessible model can still do a good job. The proof of concept study is where they put all of this into practice. They took about 2,000 abstracts from a real meta-analysis and ran their AI screening process. They compared the AI's results to what human researchers had already decided. And the results are pretty astonishing. What they found was that the AI, especially the well-known ones like GPT, could achieve accuracy very close to human screeners. In fact, for some metrics like sensitivity, which is how well it catches all the important papers, it was doing really well. They even found that using the AI could dramatically cut down the time and cost. We're talking about saving hundreds of hours and a significant amount of money. The study showed that the best performing models were the larger ones, but even a smaller local model had promising results. The prompt engineering part was key, meaning how you ask the question really matters. They also found that even with the best models, there were still some papers that the AI flagged as uncertain, requiring a human to make the final call. This isn't a bad thing, it is actually a feature. It means the AI is smart enough to know when it is not sure, directing human effort to the most critical tasks. So, what does this mean for us? It means that the way we do research is changing. Big projects that used to take years might be doable in months. It means more research can be synthesized, leading to a faster understanding of complex topics. It is like having a super-powered research assistant. However, it is not perfect. The researchers are really upfront about the limitations. One of the biggest things is that AI can sometimes hallucinate or make things up. It might infer information that isn't actually in the abstract. That is why human oversight is still absolutely critical. You can't just blindly trust the AI, you need to understand how it works, how to set it up, and know when to double-check its work. Plus, the AI's understanding is based on the data it was trained on. And that data can have its own biases. This research is a fantastic step forward in making science more efficient. It's not about replacing scientists, but about giving them powerful new tools. Imagine your doctor being able to quickly synthesize all the latest research on a rare disease that is the potential impact. It highlights the need for us to become fluent in using these AI tools, understanding their strengths and weaknesses. It is an exciting time for research, and artificial intelligence is becoming an indispensable part of the scientific toolkit. It's going to be fascinating to see how this technology evolves and how it helps us understand the world and our own minds even better. What do you all think about using AI to help with research? Let me know in the comments below. If you found this breakdown helpful, please give this video a thumbs up. Subscribe to RUBIN'S Mind Lab for more science explained simply, and hit that notification bell so you don't miss our next exploration into the fascinating world of psychology and beyond. Thanks for watching, and I'll see you in the next one.